Hey folks, welcome back. What if nature actually wanted us to be fat? What if nature had a driver for wanting us to store fat? And what if that switch is an actual switch that can be switched on and off? And if we could figure out how to switch it on and off, could this hold part of the key to solving both obesity and diabetes and metabolic diseases and gout and pretty much every other chronic disease that seems to be endemic in our society? So my guest today is Dr. Richard Johnson, and he's written his latest book is called Why Nature Wants Us to Be Fat. His two previous books were The Sugar Fix, and the one before that was The Fat Switch. So clearly, Dr. Johnson is pretty focused on solving this puzzle, or at least working towards a solution of this puzzle that is driving human obesity, metabolic disorders, type 2 diabetes, gout, cardiovascular disease, you name it. So who is Dr. Johnson? He is a professor of medicine at the University of Colorado and a practicing physician. He's been a medical scientist for over 25 years, and he is internationally recognized for his seminal work on the role of sugar and its component fructose. And I will give you a hint about the episode. Fructose is central to this issue in obesity and diabetes. His work has also suggested a fundamental role for uric acid, which has gotten a lot of attention lately, which is generated during fructose metabolism in metabolic syndrome. So Dr. Johnson, as you can imagine, is a prolific scientist. He's published over 700 papers, and his work has been very highly cited. And he is a great guest. He's a great speaker. He's very passionate about his topic, and was just a joy to chat with today. So if you get value from this episode, and if you know of anyone else who might get value of this information, please make sure that you share this episode with your network, with your friends, with anybody you think of who can get value from this episode as well. And of course, if you enjoy it, make sure that you leave us a review, because this is how we get seen. If you're looking to connect with Dr. Johnson, you can find him at drrichardjohnson.com, and the correct spelling of his last name will be in the show notes. Thanks so much for being here. Totally appreciate you guys, and enjoy the episode. Hey folks, just a little bit of housekeeping before we launch into the episode. Please remember that all of the information provided in these podcasts is for information purposes only. We are never offering treatments, cures, whatever, for any kind of disease or medical condition. Anything you hear about here is going to be intriguing. There's some research around it, but make sure that you check with your medical provider before you go off and do any of this stuff for yourself. All right. So, enjoy the episode. And also, if you're looking to connect with me for any reason, with your comments, questions, whatever it may be, you can reach me through my website, which is natnidham.com, or you can find me on Facebook in the Optimizing Superhuman Performance group, or on MeWe in the Biohacking Superhuman Performance group. And of course, you can also follow me on Instagram, which is at Natalie Nidham. Natalie is with an H between the T and the A, the second A. So thank you so much for being here. Appreciate you guys. Enjoy the episode. Welcome to the podcast, Dr. Richard Johnson. It is such a pleasure to meet you.
Natalie, the very same.
Yes. Well, as my listeners know, I always have a podcast discussion with my podcast guests before the podcast. So we actually met 20 minutes ago, but I've been devouring your book for the last little short while, actually, because as I admitted to Dr. Johnson, I may or may not have lost it in a pile of other books. And I finally dug it up the other day. And so I've just been plowing through it and loving this book. So thank you so much for agreeing to join me today. And I think that although we're going to keep this nice and tight, before we really get into the topic, which is so fascinating, what I'd love is if you might share with people how you came to this. Like, what's your, give us the 3-minute version of Richard Johnson's trail to this particular topic.
Yeah. Okay, so I'm a physician. I went to medical school. I was very interested in research. My father was in academic medicine. I really early on realized that I was that I loved treating patients and managing them, but I was much more interested in why they got their diseases than in treating their diseases. So early on, I became very interested. I went on to become a kidney specialist and also studied infectious disease, internal medicine. I'm just a very curious guy. And then I became interested in what causes high blood pressure. And there was a relationship of high blood pressure to the kidneys. So I studied that and kind of came up with a mechanism for what causes high blood pressure, which I'm pleased to tell you is currently one of the main theories for what causes high blood pressure.
Which is?
It's an inflammation in the kidney that causes the arteries, the blood vessels in the kidney to constrict, and that keeps the kidney from excreting salt adequately. So that the question is what drove that inflammation, and we've linked it with a substance called uric acid, and the uric acid is something that's in our blood, and it varies quite a bit with diet. It turns out that sugar is a major way to raise it. So I said, okay, if inflammation is causing high blood pressure, and uric acid is causing the inflammation, what's causing the uric acid? And it took me to sugar. And suddenly I was outside the kidney and studying sugar. This was like 20 years ago. And our work focused on a component of sugar called fructose. So sugar, or table sugar, consists of glucose and fructose, and they're bound together. And it turns out that it's the fructose that actually is responsible for raising the uric acid and for causing the inflammation. And then we started studying fructose, and we realized that we had found a nutrient that actually makes you suddenly lose your ability to control your weight and makes you want to gain weight. And then we started realizing it was used in nature, and that's how animals in nature, a lot of them gain weight like before they hibernate. Mm-hmm. And then we realized that it was more than just gaining weight, that fructose activated a whole survival mechanism. And it included insulin resistance and all these different things they do, foraging, blood pressure goes up as part of this story. And we realized that this was a survival pathway that animals use to survive when there's no food around, or to help prepare them for when there's no food around.
Yeah.
And then once we figured that it was a big survival type switch, then we went into a deep dive to try to figure out why it is that fructose does this and other nutrients don't. And then in that process, we discovered that there were other foods besides fructose that could activate this switch, but they did it, interestingly enough, by making you make fructose in your body. So it's still pretty much fructose dependent. And so then we realized that this was a really big story. And then we started studying that, and we found out that it was involved in not just obesity and diabetes and high blood pressure, but it was also involved in diseases like Alzheimer's disease, and cancer. And so the whole story began with a simple question, what's causing high blood pressure and why is the kidney involved? And they ended up with identifying pathways by which foods we eat are driving a lot of the current diseases of today. So it's been an unbelievable story. I'm super lucky that I stumbled on it. It's kind of like finding a gold coin. Mm-hmm. And you digging around, you find another gold coin, and then suddenly your shovel goes up against something hard, and you realize that you found a treasure chest. Yeah. And honest to God, in terms of science, this was sort of what it was like. And we published in very good journals, and it became apparent to me that I needed to tell the story to the general person, to the reader, because it came with a lot of surprises for how to treat it too. So there's ways to block this switch. There's ways to turn it into something healthy. There's all kinds of tricks that came out of understanding how it works. So that's the story. And I think I went over 3 minutes.
Yeah, no. And you know what? You kind of encapsulated a lot about what we're going to talk about today. So I want to go back and fill in the gaps for people. But that was actually a brilliant summary of where you're at right now. And I think that, identifying this biological switch that drives obesity, which is ultimately one of the things that I love about the book, and I was just telling you this, is how you're able in this book to go back and look at a lot of these physical conditions that we identify as being really negative. So be it insulin resistance or high blood pressure or fatty liver disease or any of it, or the physical storage of fat. And when you reframe it in an evolutionary context, they're not bad. These are actually survival mechanisms that help us to deal with dehydration or lack of food or whatever the case may be. And you make some, you draw very compelling parallels to nature, like the frog that lives in the desert and has these fat pads on his toes, that because we're able to convert fat into water, which is interesting because we hear, or certainly I've come across groups of people that believe in dry fasting. And so these are people who very often are carrying a lot of excess weight, and they're essentially pushing their body to go after that fat, which releases the water that they need, which means that whole kind of myth that we're fed that says you can't survive more than 4 days without water, unless, of course, you're super lean, in which case it's true, is not true. So maybe we want to just touch on a little bit of that.
Yes. So this survival plan was turned on to be an insurance plan.
Yeah.
So it's sort of like if you have some fat, you can use that as an energy source when there's no food around. And actually, every time everyone does intermittent fasting or any type of fasting, what's happening is they're switching over to using the fat they have as their energy source as opposed to the food. So what happens is the fat, when it's broken down, it generates energy. So when we eat food, we're making instant energy, which we call ATP, or we're making stored energy, which we can call fat. And what fructose does is it shifts more of the energy towards fat than to instant energy. So our instant energy levels are low, and that makes us hungry, so we eat more. It also makes us a little more tired. Our resting energy metabolism falls. And so what happens is we eat more, but we've triggered this thing, so more of the energy is going to fat than to the immediate energy. And so that's how this system works. And then when you get that fat, it's supposed to be there to help you survive when there's no food around. So it's interesting, Natalie, that studies show that, like if you have cancer, if you have heart disease, or if you're sick, or if you're over 70 years old, you actually live longer if you have a little extra fat.
Yeah.
And in fact, we always say that the ideal BMI is 20 to 25 because then you can look great on the beach, and you do. But the people who live the longest at age 70 are those who have a BMI of like 26 or 27. So being mildly overweight is associated with the ability to live longer. And it's partly because when you get an illness, like if you get COVID or something like that, you have a mild increase in fat stores, it's good. Now, if you have a large increase in fat stores so that the fat is pushing on your lung and you can't expand your lung, then COVID could kill you, right? Because you don't have as much lung reserve. But if you have just mild increases in fat, like a BMI of 26 or 27, you actually live longer. But having said that, I think all of us would prefer to have a BMI of 20 to 25. You feel better, your energy's maybe a little higher. So, but yeah.
Although at 26 to 27, you're talking about a bit of a sweet spot, right? Because it doesn't take long. Once you hit 28, 29, 30, we're now getting into the zone of uncomfortable. And we also, if we can be BMI 26, 27 with an absence of inflammation, which is, or in an absence of these other markers of disease or imbalance, if you will, that's a very different 26 to 27 than the 26 to 27 that's accompanied
Oh, you're totally right. And I actually am a big believer, shooting for that 20 to 25, even though in my book I quote the papers and we talk about it. And certainly if we were in a world where there was a lot of illnesses, I mean, like during the COVID world times, I mean, a BMI of 26 probably is better. But,
Hmm.
now, I don't think that or if you like have cancer, maybe a BMI of 26 is better. But if for the regular person, I think we should be shooting for 20 to 25.
Yeah, and that way, if you miss, you hit 26. It's not so bad.
Yeah, exactly, exactly. So anyway,
Okay.
so that the other point you made is that when we were studying animals in the wild, we realized that fat was not just a source of energy. That fat is a source of water, and that camels and animals in the desert, they use fat to help them make water. And like the frog that has the big pads, he can survive for 5 years under the sand.
Yeah.
And they he also or she or whatever, they get gulp a lot of water that they hold in their bladders too. So they actually have they're holding on to water as well as fat, and they use the fat as both energy and water source because they're in the desert and they can live for 5 years without water.
Yeah.
There's even one report said that maybe they can live 10 years.
Well, and
And
then unless they get discovered by those people that dig them up and squish the water out
yeah,
of them, which
yeah,
really
the
seems
team would
so
do.
mean.
I have a picture of that.
You did.
From the 1930s of these of the Tiwi, where they're digging up these frogs and then drinking the water from them. They squeeze it over their mouths.
Yeah.
Anyway,
Anyway,
so
yeah.
yeah, and then some animals put fat in their tails, like in the desert,
Hmm. Hmm.
like because that way it doesn't cause insulation, raise their body temp. And there's even a primate called a dwarf fat-tailed lemur, or maybe it's the fat-tailed dwarf lemur, but
Some
it's a
some
lemur.
combination of those words.
Yeah,
Yeah.
some combination of those words. And this little guy will live off the fat in its tail mainly for the water during the dry season. Um, and he'll just kind of hibernate in the hollow of a tree.
Wow.
So
Okay, so this brings us to the idea that fat preservation, we may hold on to fat, and this, it's so interesting when we get into the discussion about hydration and weight gain or fat gain, right? Where somehow the body believes that it needs to hang on to this fat because there's not enough water around, because we're dehydrated, and so it can't wait for a rainy day because that's not coming. So clearly it needs to hang on to what it's got to preserve itself. But I want to go back to the foods that activate this survival switch, because what you identify in the book is that as humans, we share this survival switch, which kind of makes sense with animals. And so, what's happened is our environment has completely turned against us because we're inadvertently triggering the switch and causing ourselves to live in a space where we're unhealthy because of.
got it. So in terms of the food, so in nature, a lot of animals will use fructose that's present in nature, and that's in fruit and honey and things that we think of as healthy, but they eat huge amounts.
Mhm.
So the bear will eat like 10 or 20,000 grapes in a 24-hour period. So I mean, it's a different magnitude of sugar, and so they're eating so much of these berries and grapes and fruits that they get a large dose of fructose. When we eat a fruit, we're getting like 4 or 5 grams to 8 grams of fructose per fruit. We usually don't eat multiple fruit at the same time. And so some do, but if you eat like one or two fruits, you're not going to get that much fructose. And it turns out the intestine kind of inactivates the first 5 grams. So if you kind of benefit with that.
So you
But
get a
you
buy.
can overlook, if you eat a ton of fruit at the same time, you could activate the switch too. And we do that when we drink fruit juices, because that's when we put multiple fruit into a blender and then we drink it fast.
Hmm.
So it turns out that for us, It's not really the natural fruit that's activating the switch. If anything, the natural fruit we're eating tends to be more tart, have lower fructose content. It's filled with good things like vitamin C and things that can actually kind of neutralize the switch. So, but where we get our fructose is mainly from added sugar. So things like table sugar. Sugar comes from sugar cane and sugar beets, what we would call sucrose, which is the disaccharide. It's a sugar that has fructose and glucose bound together. It's table sugar. That is a major mechanism. And we went from eating about 4 pounds a year in 1700 to about 150 pounds a year. And then there's this high fructose corn syrup. And that's also kind of like table sugar, except it's liquid. And the fructose and glucose are free. They're not bound together. And you can get a lot of fructose from high fructose corn syrup, and that's added to a lot of processed foods. And so it turns out that some people are eating 25% of their diet is sugar. And when you're eating that, that's half of that is fructose.
Yeah, that's
That's a
crazy.
large amount. And the average person is eating about 15% of their diet is sugar, 15 to 17%. So we're eating a lot of sugar and high fructose corn syrup.
Yeah.
And that's the main thing that triggers this switch. But originally I was thinking it was just that, and then we discovered that the body can make fructose. This was really a disappointment. And the main way it makes it is it makes it from glucose. So if you're eating a lot of glucose or foods that release glucose, they can make fructose too. And it turns out that's what French fries, starch, potatoes, rice, cereal, bread. Oh my God, I love bread. When I was a kid, I loved fresh bread. I came from a place where in my family we never had fresh bread. And one day when I was in college, I went to a bakery and I just fell in love with hot bread, hot fresh bread. And then I would get that instead of a cake for my birthday, and so it was such a disappointment to learn that bread gets converted to fructose in the body. And so it's not just stimulating insulin, it's actually converting to fructose. And it turns out that when in your early life, you don't convert it so well. You actually have to turn on this system that converts it. So in the beginning, we're kind of immune to the effects of sugar and fructose and breads because the systems to absorb fructose and to make fructose are all kind of begin kind of naive. They're not that active, but the more sugar you eat, the more you upregulate the pathway. If you give little children fruit juice, they activate this pathway over time, and it's very much linked with the development of obesity. So glucose, high glycemic carbs, what we call it, is
So
another.
yeah. So would you say that it's the one of the problems with high glycemic foods is that big hit of glucose over and over again, like those big sugar
Yes,
spikes that you see, that's the real
yes,
assault and essentially on the liver that can trigger that survival switch.
absolutely correct. That's exactly how it works. And when you eat these foods, they release glucose rapidly, so it goes up in your blood. But everything you eat goes through the liver before it gets to the blood. So the liver sees that high glucose too, and it's in the liver where the fructose is really acting. So the glucose gets converted to the fructose in the liver, and then that just starts it all off. And that high glucose also causes fructose to be made in other sites, like in the brain. And
Mm-hmm.
there's some data that, as you probably know, that diabetes and high glycemic foods are associated with Alzheimer's. And it's because in the brain, this glucose is being converted to fructose. And there's increasing evidence that that's the underlying mechanism that initiates the process towards Alzheimer's. We can talk about that more.
Yeah, I would love to. But before we do that, can you maybe take the audience through a little bit how fructose is so harmful in the body? You describe it beautifully in the book where you talk about the conversion to uric acid. You talk about the energy pathway, which depletes energy out of the system, leaving people, I mean, it ends
Yeah.
up leaving people depleted. And looking for
Yeah.
more food, more calories kind of thing.
So all nutrients are used to make energy, and we can make that energy as ATP, as I mentioned before, or as stored energy, like which is fat. So when you eat any food, it's being turned into energy, and the same thing's true with fructose. But fructose does a trick. It's a true trick. When fructose is metabolized, it activates an unusual pathway that leads to the production of uric acid. And uric acid is this breakdown product. It's a breakdown product of DNA. It's a breakdown product of ATP.
Mm-hmm.
And what happens is when you eat fructose, you consume a little ATP when you're first metabolizing that fructose, and it causes a unique reaction that's specific to fructose that triggers the degradation of ATP. And the ATP is broken down to uric acid. And once it's turned to uric acid, it's very hard to make ATP back because the uric acid has removed some of the things that are needed to make the new ATP. But even more so, the uric acid works on the mitochondria. And the mitochondria are the energy factories in the cell that make ATP. So most of our energy comes from our mitochondria. And if we don't have mitochondria, we would be slugs. There's another mechanism to make ATP, but it's a primitive system. And the mitochondria, they use oxygen to make a lot of ATP. What the uric acid does is it stuns the mitochondria, and it makes the mitochondria make less ATP. As part of that, the mitochondria will use less oxygen because they've been stunned. Remember, the mitochondria use oxygen to make ATP.
Mm-hmm.
So actually, when you activate this process, you make less ATP, and you also consume less oxygen. So it's also a way that animals, when they get into a low oxygen setting, they start making fructose, because what that does is it makes the uric acid, and it makes the mitochondria use less oxygen. So you make less ATP. So you're making less ATP, and instead you're making that energy as fat. So it's shunting it to fat. But what it's doing is it's reducing your oxygen demand. So it's actually a thing that, like animals that burrow, like the naked mole rat that goes into these burrows in Africa. And those burrows, if you're a mouse, you couldn't live down there because it gets the oxygen content gets so low that you die. But these naked mole rats will make fructose, and the fructose will stun the mitochondria, make the oxygen needs less, so they can live in an anaerobic environment. Instead, they make their ATP from that primitive system called glycolysis. So it's a primitive energy production. And so it's actually it's like a survival mechanism even there. But what's happening is it reduces those mitochondria from making ATP. And so our energy goes down, our resting energy metabolism falls in particular. So we're sitting when we're sitting on the couch, we're really sitting on the couch when you eat. You're like you're like not moving much. You're not even twitching.
Well, you're conserving energy, right?
You're conserving energy and you're using less oxygen because your mitochondria are stunned. And so what happens is the way fructose works is it suppresses the mitochondria, which is making all the energy that we need to think and do all these things. And it's trying to do it to kind of protect you because it thinks that there's not enough food around, so we're going to suppress everything. The trouble is it's great if you do that for a few minutes, but you don't want to be doing this all the time, because what happens is we start making less, the mitochondria start getting hit. Again, the way it stuns the mitochondria, it causes oxidative stress to the mitochondria.
Mm-hmm.
And so it's causing low-grade damage to the mitochondria. And so initially, it's fine. It suppresses it. Everything's fine because everything comes back up to normal. But over years and years, those mitochondria are taking a beating. And over time, you get what we call aging, because the mitochondria start to get less and less. We get slower. Our energy is not working well. And in the brain, it has very bad effect because this backup system called glycolysis isn't very good in the brain. And so what happens is the neurons start to die, and it's particularly in certain regions of the brain, and those are the areas where Alzheimer's develops. And so it's an amazing story, and now people are finding high fructose levels in the brains of Alzheimer's patients, and they can show evidence of all these pathways that fructose does before the patients get frank Alzheimer's. So it turns out that it's really looking very likely that this is a major mechanism. And all the things that can activate and increase the risk for Alzheimer's can occur with these foods that lead to either eating fructose or making fructose.
Right. And one of the things that you talk about also, because, I think what's interesting is, okay, people are sitting there listening, okay, fructose, that's sugar, and that's sugar from fruit. Fruit's bad if we eat too much of it. Like you made a good point that, an apple a day is not going to drive, it's not going to drive this mechanism. But sitting there with a giant bowl of grapes or a giant bowl of cherries and making that because people still walk around thinking, this is fruit, so I'm good. I can eat as much as I want.
Right.
Don't do that. Or even worse, fruit juice, and then compounding it with the sodas and the high fructose corn syrup, it's now overwhelming the system, right?
Right. So let me just talk a little bit more about fruits, because natural fruits, when we get a natural fruit, it has fiber, which slows the absorption of the sugar. And it has things like vitamin C, which we've shown can actually block some of the effects of this pathway.
Yeah, that was actually a great point in the book, the 500 milligrams a day.
Yeah, it contains like flavonols and these things like that are also good. So it turns out that when a fruit's tart, it actually has all these things that kind of block the effects of sugar. And animals prefer to eat the fruit when it's ripe. And the reason is because it gets ripe, the fructose content goes up. When the fruit ripens, it gets sweeter. And at the same time, the vitamin C content falls. And the plant actually, if the plant could think, it would actually want this, right? Because as the fruit matures, so that the seeds mature, so that it can make a new plant. So it wants the fruit to be eaten when it's ripe, and that's when the fruit falls to the ground. The animals will eat it. They'll then disperse the seeds in their poop, and that will help the growth of new fruit trees. So it's actually all kind of orchestrated to help the animals gain weight, and they seek out the fruit when the seeds are mature, which is good for the plant. So we call it a symbiotic relationship, something that benefits both the plant and the animal. And so that natural fruits, we actually did a study where we took people who are overweight and we put them on a low sugar diet with or without fruit supplements. And so the one group was a low fructose diet, so they couldn't eat any fructose really, but one group got natural fruits given back to them. And both groups improved dramatically. But actually, when you had natural fruits there, it was better tolerated. That people liked the diet more, and actually it had the same benefit, maybe even a little better benefit than without fruit. So I actually am convinced that natural fruits are good so long as you don't overdo it. And I definitely have had people overdo it where they're eating so many fruits that they are having trouble. They're activating the switch.
Well, and if you think, sorry, I was going to say that we've cultivated fruit that is a lot sweeter than it would have been.
Yes, we have to be a little careful.
Yeah, sorry.
The other thing is the other big discovery. Well, there are quite a few, but when we realized that fat was being used as a source of water by animals, we began to realize that, if you were dehydrated, that might make you want to put on fat, because if you were mildly dehydrated, you would probably want to accumulate fat. And so it turns out that people who are overweight are almost always mildly dehydrated. I don't know if you know this. It's sort of surprising. But there have been studies that show that people who are overweight or obese tend to be, one study showed that they were 12 times more likely to be dehydrated than a lean person. That's a big deal.
Yeah.
And then the question is, well, how do you get what's making them dehydrated? And part of it is they're not drinking enough water. So it turns out that if you're not drinking enough water, that's a risk factor to become obese. But if you could still be drinking water, but you can make yourself dehydrated by eating salty food.
Yeah.
So
So this was the
salty
other piece
food,
of it. Yeah.
yeah. So it turns out that when you're dehydrated, we often call it because you're losing water somehow. For example, like vomiting, diarrhea, sweating,
Mm.
you're losing water, so you get dehydrated. So the water in your body is actually low. But you can increase the water in your blood by eating a lot of salt. So when you eat a lot of salt, it makes you thirsty, and so then you drink more water because of that. And it's not because you've lost water, it's because you've gained salt that makes you gain water.
Mm-hmm.
So it turns out that when you eat salt, it's a kind of a way to hold on to water. But what's really interesting is that when you eat salt, it activates that switch to make fructose. And so it turns out that salt is another stimulus for making fructose in the body. And the reason is then the fructose helps you store fat as a source of water. So it's another way to help you drive, to help correct for thirst by storing up water. So when you eat salt, you become thirsty, but then you're drinking water, but you also start making fat to help you
Preserve it.
survive. So salt licks that animals find are probably there to help them store fat, which they often need.
Yeah.
Many of them are eating poor quality food that doesn't have a lot of nutrition, and so if they activate a system that helps them make fructose, then what will happen is they can store fat better.
Mm-hmm.
But you're making that fructose from glucose. You're not making it from the salt. So the salt is activating the system, which I call the polyol system, that helps convert glucose to fructose. That's why French fries are so bad, because
I was just, I was,
you got the potato, which is your starch. That's pure glucose. You put salt on it, a little bit of grease and stuff to make it really taste good. And it does taste great. And what's happening is the salt is like the fire that turns on the enzyme to help convert that starch to fructose.
but you forgot one piece. You
Go
forgot
ahead.
you forgot the ketchup.
Yes, the ketchup.
Which itself is a source of fructose. Like if you think about
Exactly.
it, I had just written this down to say, like French fries are the perfect, they're the
Yes.
perfect food to get obese on, because you've got, to your point,
Yes.
you've got the starch from the potatoes, you've got the unhealthy fats, which we know are bad in a million different ways. You've got a ton of salt, because what's French fries without salt? Like, it's like the French fry that fun forgot. And then you dunk them into whether it's gravy, which is also probably full of sugar, and ketchup, and you're
Bingo.
boom.
Yeah, boom. Yeah, so this is why the low carb diets are so beneficial, because not only are they removing sugar, but they're also removing these high glycemic carbs. And so even if you eat salt, but you are on a low carb diet, you don't have as much glucose to convert to fructose, because you're getting, you're restricting carbs. So you're getting less glucose in your diet. You're still making some glucose from proteins and stuff, but most of the glucose we get is from our starches and stuff. So when you remove that, then what's happening is the salt isn't as capable of inducing obesity. So a low carb or a keto diet is a great way to help turn off this switch, because it basically removes the glucose that's used to make fructose, and it also reduces the fructose, because they're both carbs.
Right.
You still make some carbs though, but you really, this is a great way to really reduce the switch. Another is just to try to cut back on salt, drink
Yeah.
more water.
Well, because keto diets can be quite high in salt. And, we've all seen keto diets backfire on people.
Yeah,
I think that, you get these dirty keto diets, as they're called, which are full of processed foods.
yeah.
And a lot of people will say, well, what's wrong with the keto diet? My carbs are still super low and my fat's super high. And it's, we try to oversimplify things as much as possible, and we forget that the devil is in the details when it comes to our bodies and nutrition. And
You're so right.
eating a bunch of processed food, and people on a keto diet are told they need more salt, which they kind of do,
Right.
but to pound the
Yeah.
salt with reckless abandon. And
Yeah, no, you're totally right. What I've been learning, originally when we were beginning, people were just talking about it as calories, or, it's calories that count.
yeah,
And then we realized that it was not just calories. It's like it makes a difference if it's protein or carbohydrate or fat. And then we've been learning that it's actually types of fat and types of protein
mm-hmm.
and types of carbs. And now we're getting to even a newer rule, which is how you eat it can make a difference. And I'll give you an example. The way this switch works, it relates to the concentration of fructose that gets to the liver. So the higher the concentration, the bigger the activation of the switch. It's
Right.
like a dimmer. It's like a dimmer. So if you hit it with a lot of fructose very quickly, it's turned on full blast and you're like trying to make fat. But if you activate it slightly, then it's like only half up the dial. So it turns out that if you had a soft drink and you drank it fast, you'd get a huge amount of fructose in a very short time. And so it would flood the liver and you'd get this big activation. And even though it's a huge amount of fructose, if you drank it really slowly, like you had a
Right.
Coke and you sipped it all day long and it took you like 4 hours to drink it because you were just sipping here and there, it would just be a calorie. It would not activate the switch
Yeah.
because the concentration that gets to the liver would be very low because you're drinking it so slowly that only a tiny bit is coming in. Or here's another thing: if you drank a soft drink on an empty stomach, it's going to be really bad. But if you drink it with all kinds of other foods that are going to slow the absorption and fiber, it's still going to be bad.
Yeah.
But it's not going to, I'm not trying to
Well, no, because
recommend
you do make the
soft
point in the
drinks, but
book. Yeah, you do make the point in the book that sugar plus fat is the easiest way to drive obesity in animals, and like a high
yes.
sugar plus a high fat diet together is one of the surefire ways to make animals obese. But I wanted to ask you about something else. Have you looked at all at resistant starch, like
You
and the
know,
difference
I
of yeah.
I've seen some studies. It looks really promising as a
Mm-hmm.
good way to go. So resistant starch is starch that does not break down very quickly. And so it has that benefit where it doesn't make the glucose go up in the blood. And so it turns out that the way fructose is made, it really is triggered by a rise in glucose above what's normal. So if your glucose level is normal is like 80 to 100 in our body. And as far as we can tell, there's very little fructose being made between 80 and 100. There
Interesting.
may be some though.
Mhm.
It may turn out that this is important in aging, even for people who are doing everything right. But it looks like from 80 to 100, there's very not much fructose made. Once you get to like 120, 100 to 120, there's probably not much either. It's maybe a tiny bit. But once you get to like 130, which often you can hit if you're eating like a potato, your postprandial or your glucose level after you eat can maybe hit 130, 140, 150. That definitely triggers it. And of course, if you eat a small amount of glucose, but you eat salt with it, like a French fry, you don't necessarily have to get the glucose up. So because the enzyme's turned on big time. But anyway, so yes, you're totally right. It probably the glucose level makes a difference, and resistant starch tends not to raise that. So it should be a much safer food. And I've seen some data that suggests that's true.
Yeah. Yeah. No, it gets metabolized. I mean, to your point, it gets metabolized by the body quite differently. So there's one more food category I want to touch on. And then I really want us in our remaining time to talk about some of the disease connections you've made with cancer, with heart attack. Like, I think that's a really, really great discussion. But the final category of food, and I think this is probably the biggest disappointment when you're reading the book, you're like, come on. And that's umami, foods with umami. And it all is predicated on this content of glutamate that also feeds into, in a different way, feeds into this cycle of driving, I think it's uric acid production, right?
So it turns out we have 5 tastes. 2 of them we've talked about, sweet and salty. 2 are sour and bitter. The sour and bitter developed to try to help us avoid foods that probably could be poisonous or things like this. But the sweet and salty were developed to help us find these foods just for this purpose of putting on weight. Okay, and if you knock out the taste and you still give sugar, animals will still love sugar. So it's not the taste that drives the sugar. The taste is there to help you find the foods that are sweet. And the body wants us to eat this. Nature wants us to eat foods that are going to help put on fat for us. Because in our past, survival was key.
Yeah.
Not so much now because food is available all the time.
Mm-hmm.
So the 5th taste is umami, and we call it the savory flavor. And it's when you age or cure foods, it can release an amino acid called glutamate. And you can get glutamate in like tomatoes too, like the Bloody Mary has a fair amount of glutamate. And glutamate's also present in yeast. Yeah, so like yeast extracts are used in beer. So one of the reasons beer tastes so good is because the brewer's yeast contains a lot of glutamate and other substances called IMP and AMP. They're nucleotides, and they also play a role in these flavors. So people make MSG, or monosodium glutamate, and they add it to foods because it makes the savory taste. And a lot of Chinese restaurants have a lot of glutamate, and a lot of Asian foods have a lot of glutamate. Unfortunately, no one really understood why this was, right? And so we started studying this, and we realized that glutamate actually gets broken down into uric acid. And when you give glutamate to an animal, especially in the drinking water, they'll become incredibly fat very quickly. Now, the difference is, you say, well, there actually were studies showing this before us, but what we found is that glutamate is a really potent stimulus and that it works through the same pathway that fructose does. It just, remember, fructose makes uric acid?
Yeah.
So glutamate makes uric acid, and so it's another route to that path. And then the uric acid suppresses the mitochondria and that whole bit and activates the switch. So glutamate activates the switch too. And it turns out that these other substances that people add that are part of the umami taste are actually part of that exact pathway that makes obesity that we fell upon. And so the good news, Natalie, and this is probably why animals start, seek bone marrow, because it's very rich in glutamate and these things that can drive food, that can help put on fat. And it's also why certain foods like shellfish and liver are so tasty, and shrimp and lobster, because they tend to be rich in these purine. We sometimes call them purine-rich foods, but it's basically foods that are umami. They're really the same. Now, the good news, there is some good news here. The good news is that it takes a lot of umami foods to be the equivalent of what the sugar we're eating. So we're eating like 75 grams of sugar a day, and we're eating like 2 grams of glutamate a day.
Yeah.
And although 1 gram of glutamate is stronger than 1 gram of sugar or 1 gram of fructose, it's stronger. but we're eating so much less glutamate that it's not a major mechanism for obesity.
Okay.
And most of the umami foods we're eating we're not eating enough to really drive the switch. Now, if you happen to be like fried shrimp, which I do.
Mm-hmm.
I mean, I
Mm-hmm.
love fried shrimp. I don't know. I mean, unfortunately, shrimp contains a lot of this stuff.
Yeah.
So it's not the one shrimp or the two shrimp or the three shrimp, but when you have a bowl of shrimp, you probably are getting enough umami to activate this pathway. And also, if you're a beer drinker, beer, even non-alcoholic beer, contains this stuff, and it's probably why there's a beer belly, why beer raises blood pressure, why beer raises triglycerides and causes fatty liver. It's through this very pathway.
Yeah.
So it's sort of disappointing. And we've always kind of known that the other than sugar, beer is one of the most strongest way to make you overweight.
Mm-hmm.
And it's because of the umami and some of the alcohol. And another thing is alcohol. Some alcohol gets converted to fructose in the body too. So it turns out that we have to be careful. If you get my book, I promise you, I lay out a way that you can. I mean,
Right
I
here.
do a balanced. There are solutions here. And you can still have a balanced meal, and you can still eat some sugar here. You can still, but anyway.
I think it's the accumulation, right? It's a little bit like you don't eat one French fry and you eat the French fry with the salt and the ketchup. You don't eat one fried shrimp, to your point. There's probably a dipping sauce on the side somewhere for that shrimp. Like we're our own worst enemy. We're not eating just the one thing. It's the cumulative effect of all the things. And we were talking about this a little bit when it comes to red meat, because red meat is a very hot, ugly topic right now. You want to get a lot of people mad at you to start talking about red meat. Either it's really good or it's really bad. And you're going to have all kinds of people coming at you. And I still believe, and I know that you talk about red meat being a source of umami in the book. But I think one of the things that is important to mention is a lot of it is the processed meats that are
Yes,
the umami.
without a doubt, processed red meats are much worse in terms of umami.
Mm-hmm.
They often have a lot more salt and sugar as well.
Yeah.
If you compare red meat to white meat, there's more umami in red meat. There's more IMP and AMP. Same thing with shellfish. But again, it's a matter of balance. If you have kidney disease, you definitely don't want to be eating a lot of red meat.
Yeah.
Because animals, you can definitely make kidney disease worse by giving them animal proteins that are higher in umami than vegetable proteins. So, but I recognize that there's a lot of positives to meat, and one of the best things about a paleo diet or carnivore diet is that you're reducing your carbs.
Yeah.
And so there's a lot, that is a huge plus.
Yeah. So let's get to these other topics though, because I know we don't have, we still have about 20 minutes left ish. I know you have a hard stop. So let's talk about the relationship of all of this topic to cancer. I think you have a fascinating part in the book talking about how the polyol pathway gets activated in the heart in a heart attack, which further drives the damage. So I don't know where you want to start there, but yeah. I do think
let's begin with cancer because it's a little bit easier to understand.
Mm-hmm.
So many years ago, it was recognized that that cancers, when they spread, especially when they metastasize and when they form, they usually do not have their own blood supply initially. And so when a tumor cell spreads through the body, what we call metastasis, it's in an environment where there's not a lot of oxygen initially. And then what it does is it actually stimulates its own blood vessels.
Mm-hmm.
And then at that point, then it can keep growing. But it lives in a low oxygen environment for the most part. Now remember that this survival pathway developed for animals that as to survive when there wasn't enough food around or energy, but oxygen is used to make energy too. And so if it was kind of to help you survive in a low energy state, it wants to reduce your oxygen needs. And the way it did that, if you recall, is that the switch turns down the mitochondria, which use oxygen to make energy,
Mm-hmm.
and it turns on a process called glycolysis, an ancient system that makes small amounts of energy but doesn't require oxygen. So it turned out that many years ago it was discovered that cancer cells often live off this primitive energy mechanism where they can live with, they don't need the oxygen to make their energy. They switch to this thing, and it was named after a guy named Warburg,
Yep.
Otto Warburg. Call it the Warburg effect. So for years, since 1930, it's been known that cancer cells prefer to live when they're living in this low oxygen environment, they actually live off glycolysis, where they're trying to make energy without requiring much oxygen. So guess what their favorite fuel is? Almost all these cancer cells, there's all these studies showing that they love fructose because
Mm-hmm.
fructose helps them by reducing the oxygen needs. It helps them grow in this low oxygen environment. And so it's like their favorite fuel. And if you give, tumor cells in culture, they grow more with their fed fructose. And we actually gave them uric acid and did studies with uric acid, and they metastasize in the animal much faster if you raise the uric acid.
Hmm.
It's been known that cancers are commonly, a number of them are commonly associated with obesity, in which the switch is turned on, right?
Yeah.
And so breast cancer, and pancreatic cancer, and colon cancer, liver cancer, these are the main ones that have been associated with obesity. And guess what? They're associated with a high uric acid. They're associated with sugar and with fructose. And there's even some groups that are taking animals and putting them on low sugar diets as a means to slow cancer growth, especially like colon cancer in animals. So it's not going to be long before this is being investigated in people.
Right. Well, there's already quite a movement of people with cancer exploring a ketogenic diet. And in some
Yes.
cases, it's really helpful. But I have also, and I know personally someone who unfortunately has passed away since that, even a keto diet wasn't able to help her. But my understanding is there are certain types of cancer that can actually even use ketones as a source of fuel. So it seems to
Probably.
vary between types of cancer. I think we're moving away from the blanket statement, oh, you have cancer, get on a keto diet, to learn more to
Yeah.
see if your
Well,
cancer is
some
that
of these for
cancer.
sure, fructose is bad. Whether or not ketones are bad is another excellent question. But
Yeah.
it is the way it works. This is probably why these cancers are associated with with obesity, for example. Now, the other thing that happened is that we realized that part of this survival response that is activated by fructose involves the stimulation of foraging. And foraging is where you start looking for food. You're hungry. You go out into an area where you may not have been before. So there's a little exploratory behavior, a little bit of risk taking, because you may go into an area where there's predators. You have to be brave. You have to be maybe a little aggressive in case you run into something. And you have to move fast. And you can't spend much time deliberating on anything. If you're looking around, you got to just kind of go from one area to another and look real quickly. And so there's not so much attention to detail because you got to get through. And so it turns out that fructose has been shown in neural imaging. When you do imaging of the brain,
Yeah.
you can actually look for where things are blood flow increases and blood flow doesn't, and you can tell what's being turned on and off. And it turns out that fructose tries to make the visual cortex stronger so you can see more. And it tries to decrease the willpower area so that you're more likely to go into an area that you know may not be safe. It actually downplays the area of recent memory. It doesn't want you to remember where the predators, I mean, it wants you to know, of course, but it doesn't want you to know so much that you won't go into that area because you've got to come back with some food.
Mm. So is
And
this,
so all these things get activated by fructose.
yeah.
And now there's data that like fructose levels are high in patients with Alzheimer's. It's high in patients with bipolar disease, especially during, associated with manic episodes. And there's more and more data that this pathway is kind of playing a role in some of behavioral disorders and dementia and so forth. So it's really a very exciting area of research.
What about in kids? Like, as you're describing this, I'm sitting here thinking about, small children. And you talked earlier how these pathways aren't necessarily activated in kids. But if we look at some of the diets that some of these children are following, they're getting sugar from right, left, and center, including fruit juice and whatnot. Like in kids with, with all these attention deficit disorders or behavioral issues in school, like this sounds a lot like
Yeah, no,
that.
it's very, very much involved. And so it turns out that when you're born, these systems to make and absorb fructose are pretty low in your body. But if you expose a person to a lot of sugar early in life, they'll start absorbing, and eventually that fructose is kicked in, and childhood obesity is a big issue.
Sure.
And ADHD is actually associated a little bit with obesity, but it's particularly associated, it's been linked with sugar intake, and most teachers and most parents have thought that it was linked. Now, there's some people who pointed out that it's hard if you give sugar to someone, you can't always get that ADHD kind of symptom. But it turns out that the way this system works, and I had a couple papers on this, but the way it works is that the more sugar you're eating, the more you're turning the system on, and the systems will eventually, your uric acid levels don't just go up with fructose, but they stay elevated. And once they're still elevated, you can have ADH symptoms even without eating sugar.
Yeah.
And so the problem is that, if you're going to do a study, you have to look at whether or not the uric acid levels are normal or high, and whether or not they respond to the sugar. So some people are going to eat sugar, but their uric acid is not going to go up as much because they're not going to absorb as much sugar because they've not been exposed to as much. And others are going to get sugar and they're going to absorb the whole thing, and their uric acid is going to go up much faster. And so to actually study this, you have to understand the pathway and then design it so that you're actually seeing if the switch is being triggered or not. Because if you're not triggering the switch much, you're not going to see it.
Yeah.
And so anyway, when you actually look at children with ADHD and you do the imaging and everything, it's the same fingerprint as what you see with sugar. It's the same fingerprint.
Yeah.
And there are nice studies that have been done by Michael Gorin. I don't know if you've had him on your show. He has a book called Sugar Proof. And he's a pediatric sugar expert, and he's done these studies where he's given sugar to adolescents, and he can show that this hyperactivity followed by crash, this is real. It's
Yeah.
actually shown in people, in
Well,
kids.
I
So
think,
I think we can learn a lot. One of the fantastic things, Natalie, I mean, it's fantastic, is when we found this pathway, suddenly it can help explain so many different things. It's like, that's why I talk about it as a treasure chest. And so I'm hoping that as we learn we learn how to fix things. We learn how to prevent, treat, reverse. And in the book, I talk about the tricks to reverse this, because even if you've got the switch activated for a long time, there are ways you can reverse it. I think it's going to turn out to be a major mechanism, not just for these diseases, but aging.
Hmm.
Right now, we're studying aging. And when we block this pathway, animals don't get aging changes in their kidney. And they don't get, their blood pressure stays normal their whole life, and they stay lean. So I have the feeling this is, that fundamentally this is a major pathway. I'm incredibly grateful that my research allowed us to stumble onto this. And I do believe that it's going to, as we learn how to block it, we're going to knock out a lot of big diseases.
Yeah, no, it's really, really exciting. So I think, and it's funny, I was going to ask you about once the switch has been switched on, what does it take to switch it off? And I gathered that's at the end that's the last chapter of the book that I didn't actually get to. But is
Yeah,
there, so as we close, maybe we could
yeah,
leave the audience with this,
yeah,
a little bit of hope and a couple of
yeah.
strategies.
Okay. So there's two things to think about. One is there's this switch that we turn on. It isn't just from sugar; it's from eating these other foods too. And we turn on this switch that helps put all this fat on us, make us diabetic, and all these things. And if we stop the switch, we can reverse back to normal fairly easily, at least in the early part. But once you've been obese for a long time, like
Hmm.
5, 10 years, it isn't enough just to block the switch. You actually have to stimulate the repair of those energy factories. Because what happens is you're hitting them with this thing called oxidative stress. Think of it like a hammer.
Yeah.
And you're hitting it every day, okay? And it takes a long time to knock it down. But once you start knocking it down, then if you take away the hammer, you're still stuck with not enough mitochondria to make the ATP we need to give us the energy we had in our youth. And so at that point, we're still walking slowly. We go on a diet, we lose the weight, and the weight comes right back up when we break. We can't maintain it. There's too much of a drive to take us back to that high weight. And so the question is, how can we get to the point where we can eat what we can eat what we want. We don't have to eat 400 calories a day to try to keep our weight down. We can
Hmm.
eat a regular diet, and the trick is we have to restore the mitochondria. We have to restore the mitochondria. And
Interesting.
that's the second half, and there are ways to do it. There are actually ways to do it. There is no one who can't get back a lot more energy, and it's going to give you back youth, and it's going to give you It's going to make you less likely to develop cancer. I mean, it's going to have a lot of benefits, and it's not that it's all been proven, but the data strongly suggests it. I mean, I'm a scientist. Some of this has to be proven, but the data really supports it, and I talk about it. And the number one way to restore the mitochondria, there's like multiple ways. But one of the best ways is with what we call zone 2 exercise.
Nice.
And what that means is you get on a stationary bike, or a bicycle, or you walk fast, and you just kind of force yourself to walk to the point where it's just a little bit difficult to talk. You can still talk, but it's a little difficult. That's when you're in the zone. And for some people, it's going to start off with, you're still walking slow,
Hmm.
but for you, you're in the place where you want to be, because you want to be at the stage where you just are having a little trouble talking. And that's the stage you want to be in. And then bad news, you have to exercise probably at least 40 minutes, 30 to 40 minutes to really get the benefit. If you just do 5 minutes, it's going to give you a tiny bit of benefit, but it's not what you really want. What you want to do is to do this like 3 times a week, and to do like 40 minutes, 30, 40 minutes. And what will happen is these mitochondria will start coming back. And when it does, it's going to be easier to keep the weight off. You're going to feel better. You're going to have more energy. You're going to sleep better. and everything's going to be good, but you're still going to have to avoid activating the switch, or you're just going to be
Sure.
bringing back the mitochondria, and then you hit it with a hammer again. So you don't want to do that. But anyway, it is. I think anyone can really gain a lot of benefit by following some of these basic rules. I mean, if you have been diabetic for a long time and you're on dialysis, and it will be a harder go, but you can still gain. You can still get benefit. There's benefit for everybody.
Yeah.
And it even brings back muscle. So we have some data in animals that that we tend to waste away as we get older. Our muscle gets less and less, and you probably can get your muscles back by doing this. And it's not the calories you burn from exercise. Um, it's not just the flexibility and all those things. Those are all great, okay? But it's the stimulation of those energy factories. That's what counts. That's how the brain works. That's how we want to stay healthy, is to keep our energy factories good.
Yeah. Well, it all comes down to the mitochondria so often. And there's lots of other ways to help with mitochondria. There's red light, near infrared light therapy. We talk about mitochondria a lot.
Oh, okay.
And I think, to your point, I think the only question that somebody might be wondering, and I'm staring at my clock here just to make sure I don't take you over, but, does that 40 minutes have to be continuous, or can they do 15 minutes 3 times a day, do you think?
I personally think you can do the 50 minutes 3 times a day. I do not absolutely know.
Yeah.
Um, There's a person who's expert on this who you may want to invite to your show, Inigo Samalan. He's kind of the international expert on this.
Yeah.
And he also was the coach for the Tour de France winner.
Oh, yeah.
And so and he understands how to optimize
Yeah.
mitochondria better than anyone in the
Yeah.
world.
Well, I'm just,
I,
I'm
I would
thinking.
reach out to him.
Yeah, I'm thinking about someone who's very overweight, who hasn't exercised in years and years and years. To them, that 40 minutes can seem like an insurmountable mountain, whereas those 3 or 4 10-minute blocks
Yes,
is more achievable. Plus,
do
you do it
that.
after a meal, it lowers your postprandial glucose.
Yeah, I honestly believe that 3 10 minutes or 4 10 minutes would be just as good. I
Mhm.
really believe that. I know that for a fact? No.
Yeah.
But I can't tell you definitive, but I totally in agreement with you. And to be honest, I tend to I like to do it in like 15-minute blocks
Sure.
myself.
Yeah. Okay. Well, I know that you have to fly. So why don't, and I mean, there's so much more we could talk about, guys. There was so much in this book that I wanted to dig into, and we only have so much time. So, Dr. Johnson, why don't you tell people where they can learn more, where they can find your book, which is fantastic. And it's a really easy book to read. I mean, I think you've made it very accessible for people, which
Thank you
is
very much. I
important.
had great editors helping me. So the book is from Ben Balla Publishers, but you can find it at almost any bookstore. It's called Nature Wants Us to Be Fat. I've got it right here. And so I also have a website, drrichardjohnson.com. And I have lots of little pearls on that website. I have stories that are not in my book. So that's a place where you can kind of learn more about me. And so, yeah, Barnes and Noble, Books a Million, all the bookstores,
All the places.
Amazon. So you can find it. And I appreciate your interest in it. If you do see it and you read it and you want to write a review about it, please do. Preferably a good one.
It's all about the reviews. Yeah.
Yeah, exactly. And if you really get a major question, you can email me. I have a lot of people finding me either through the Ben Bella. They have a site there where you can email. Some of you may email me by looking me up in my academic papers. I am a prolific writer. Well, I shouldn't say prolific, but I write a lot of papers, and so that's it.
And no doubt through the website. So thank you again so much for your time and for being here today. I so appreciate it. It's been
Thank you,
great.
Natalie.